I'm Graeme Speak, the founder of BankVault Cybersecurity. In June 2021, passwordless authentication became the highest funded sector in cybersecurity. The analysts are predicting 90% adoption across industry as it grows from 45 billion in 2021 to 456 billion by 2030. It's 30% compound annual growth rate. We've pioneered this space since 2015. 6 patents filed worldwide, 5 products in market, and we've just released MasterKey, which allows any website to go passwordless overnight. And that is about 10 to 100 times faster than other solutions on the market. In passwordless authentication, passwordless does not mean frictionless. In fact, it's quite clumsy in most cases. This is our differentiator. Our technology is essentially invisible to the user. There's nothing for them to see or to actually set up. And that makes it so much simpler. It's a huge advantage. The problem we're addressing specifically is called endpoint hacking. It's where the user's browser on their device has been compromised. This is the vast majority of all cyber attacks. Cyber attacks don't typically target the endpoint servers, the end user servers, because that's behind the firewall. It's always the end user's device. When a user is entering in their username password, they see asterisks in the password field. This is purely a mask for the people sitting behind them. Any software in that browser sees this as clear text. So if a password manager is being used, the moment it loads your encrypted password into that web form, it is no longer encrypted. It is now clear text, intercepted instantly. Remember, you haven't pressed transmit yet. So password managers expose our credentials to malware. There's nothing that they can do to stop it. It's one attack surface. The industry's solution to date has been two-factor authentication. It's a really good idea. It is clumsy. You do it as a last resort because you have to, because it's such a pain in the neck for everybody. There's a cost to deploy it. There's a cost to support it. And it's not infallible. If I've hacked your browser, I've only got to change the bank account numbers that you're going to pay when you load up your list of creditors. Move the decimal point, and then you authorize it with your fob, you Google Authenticate. The 2 most precious assets on your balance sheet are your cash of bank and reputation, while you spend the next 10 months arguing with the bank, proving you're not defrauding them. These left overnight. So account takeovers is a massive problem. The approach that the industry has been taking, which is what we call Cybersecurity 1.0, where it's detect the next type of threat and then counter it, is failing by the numbers. These are growing exponentially, and one analyst predicted $6 trillion to the global economy in 2021. There is a new generation of technologies which we call Cybersecurity 2.0, where the approach is different. Security is baked in at the foundations, and leading this today is passwordless authentication. For an organization, this provides users with frictionless access. That increases engagement. If you can also provide better security, that increases user trust. So this is actually a win-win for the users. And that becomes a competitive advantage and business driver for the organization. If what the analysts are saying is in the next couple of years, this is growing wholesale across the market, then your customers are simply going to expect it. It's a good idea to get in and actually start doing this now. Or potentially they can walk across the street to somebody else who does provide this. There are some great solutions on the market. All of these are solid. They all suffer from the same roadblock though. This is a major implementation project. You're going to change the way you're measuring identity at the back end. You've got a data migration to go through. You've then got to deploy client software to the users. You've got a massive change management in educating those users to go through these changes to install and configure the system. And the scarcest resource any organization has is the A team overseeing this. It has to get it right, or everybody's offline. We've actually solved all these problems. So MasterKey is actually a protocol, and it's invisible to the user. We're harnessing the user's mobile phone's browser, so there is nothing for them to install or configure. It's deployed from the very front face of an organization's web server. This is a cosmetic change. We are not an identity and access management system. This provides the seamless integration with or interface to that identity and access management at the back end. So that's where we fit. There are 3 component technologies: an encrypted invisible keyboard, which captures the credentials of an existing user, or can generate this seamlessly behind the scenes so the users never even need to see it. We then retrieve this to create a passwordless experience, and this is multi-factor, done in one step that's invisible to the user. So the user experience, when they go to the website, it simply recognizes them and logs in with their mobile phone or a tablet. On a workstation, we want to drag it back to the mobile phone. So what we do is we'll present a QR code. If you scan it with your mobile phone camera, it simply transfers onto the mobile, authenticates you, and your workstation logs in. There is nothing installed on any device, and there is no obvious user setup. What I'd like to do is I want to demonstrate this to you right now, and I will send you the link so you can actually just try this yourself on your own phone. So let me exit the demo here. I've got a simple login page here, and I just want to go through a thought experiment. Let's assume that, for example, we're selling this to a university. So we've been talking to the university for a few weeks. The guys have got their head through it. They're happy that there is no security risk, and I'll explain later. And they're happy that there is no technology risk. Again, I'll explain that later. And so on Friday afternoon at 4:30, they're going to add 20 lines of code to the login page. It's in the web server. This is a cosmetic change. And if you're on a workstation, you'll see a QR code. If you're on a mobile or a tablet, there's nothing. So everyone comes into uni on Monday morning. There's a QR code on the screen. If they're under pressure, they're going to ignore it. Tuesday comes along, they've got their routines, they know what they're doing, and they're busy. They're just going to keep doing what they usually do. It's not until maybe Wednesday or Thursday that there's a little bit of time up their sleeve. There's a QR code being on the screen all week, and there are 3 words: scan to log in. And they trust the organization. So I'm going to grab my phone here. I'm simply opening the camera. If I point it towards the QR code, it wants to open up a web link on my mobile phone. And all I've done is I've transferred that page onto my phone. On my screen here, I now ask for my username and password, which I know. I'll enter it as usual. And when I press log in, my screen fills with asterisks and it logs me in. You can see here, this application's demo is simply showing what it called at the back end. Has my username, hello, my password, world, and the device signature of my mobile phone. Two-factor authentication is something that you have, your mobile phone, and something that you know, your credentials. And it captured this in a way that was completely invisible to me as a user. Now, if I come back in tomorrow and I do this again, I'll scan this with my phone camera. And this time it recognizes me. And I'm just going to hold this up to the screen. You might see it there. It recognizes me as a user called hello. I'll just touch that. My screen fills with asterisks and it logs in. I never need to remember or enter my credentials again. This will work off any device. And if I'm on a mobile phone, I want to just explain that experience to you. I'm just going to shrink this down and pretend for a moment we're on a mobile. I'm going to press log out. When it comes back in again, it recognizes me straight away. It wants to log in as a user called hello. I say, okay. And it logs me in. Username, password, there's my device signature. I'll log out again. Straight away, it comes back and wants to log me back in again. That's it. This is so simple. So what we've created here is multi-factor authentication with something that you know, your credentials, something that you have, your mobile phone. And some people will say, well, what if I lose my mobile phone? Well, the San Bernardino terrorist phone couldn't get cracked into by the FBI. Security on mobiles is actually extremely strong these days. But if you need more, of course we have it. And this is, we can use your fingerprint, your Face ID, a screen pattern to prove that you are also present. This is what is called the FIDO2 standard for authentication of passwordless authentication. And the kernel of that is WebAuthn. If any organization is deploying this, it is normally a very large, very complex project. And yet what we do here is allow our customers to deploy this without any development. We'll literally just simply flick a switch. There is no single point of failure with this because the users can always log in with their username and password. We're not removing that. And so this also allows you to set up multiple devices quite easily if you deem that necessary. So the approach here is, as we said, 10 to 100 times faster than other solutions on the market. Every website on the planet today has username and passwords. The problem is not that. It's always behind the firewall. The problem is always on the end user's device. And in our model, there is no client software and there is no user setup. And that means that the change management project literally dissolves. This model is also zero trust. You don't have to trust the system. The web server is generating the security secrets and never lets those go. Without that, you would need billions of years to decrypt what's going on here. And even if you did, you'd be left with contextless, meaningless encoded data. I'll cover that in a moment. So a typical implementation project is simply clone the login page and put it onto a secret web address. Add 20 lines of code, put some test data through it just to get your head around it. If it's working, give it out as a proof of concept to a few choice users. If that's succeeded, then expand it to a small pilot, perhaps 1,000 users. If that's working, canary rollout just continues to expand the pilot until everybody is live. The work between each of these steps is exactly zero. It's purely a function of who has access to that login page. From the risks point of view, there is no technology risk. As I said, there is no single point of failure. The users can continue to log in as normal if you wish. And there is no security risk. This is the user's normal input. What we've done is we've abstracted it away so they never enter it again from their device. It's now controlled by the web server, working in concert with their mobile phone browser and their Face ID. One of the most interesting people on our team is actually Whitfield Diffie. Whit Diffie is a Turing laureate. The Turing Prize is like the Nobel Prize of the IT industry. He created an algorithm called the Diffie-Hellman key exchange, which is the algorithm underpinning internet encryption today. He's an industry icon. So the ask here is really just to test drive this with your own website. As I said, the integration is a little API with 20 lines of code. It's a cosmetic change. There is no security risk behind this. It's very, very simple to do. Or just simply hop online with one of us and do it with a Zoom call. You can experience this within seconds in your own hands. And I think that strips away a lot of the mystery. What I will do is explain it now in exactly the technical terms as to how it works. This is really interesting in the kernel of the intellectual property. We are always harnessing the user's mobile phone's browser. You enter your username through a normal keyboard. When you touch the password field, we invert the architecture in your keyboard. It's replaced with a projected image of a keyboard in an inline frame. This is effectively a firewalled separate browser. This keyboard is an illusion. There is no keyboard. It's a photograph. This could be pictures of animals, could be Chinese characters, anything at all. What we're actually doing is setting up encoded cells on the screen. So if you press the cell that is above the letter A, we never generate the letter A. We're going to generate perhaps 48 characters. And the only place in the universe that can interpret this is the web server, which generated that security secret a moment earlier. It becomes a character inside the web server. It stays there. The web server projects an image of an asterisk back onto the user screen. It's a cosmetic change. We also pass through the device signature of the mobile phone. This is the first layer. Let me expand on it now and describe the protocol. We've got two endpoints, the mobile phone and the web server. And between here, we have two stages. The workstation QR code is there purely to allow the phone to scan it and transfer that page back onto the mobile phone. So every time a web server sends out a login page, it generates a unique security secret, keeps part of it private, and it has part of it public. The public part of this key is enough, or security secret is enough to encode the screen. But what we do is we generate more security secrets on the mobile phone. And the algorithm combines these secrets together to encode the screen. So you press the cell above the letter A, we're going to generate 48 characters, and we go to store it. Before we store it, we encrypt it. We've now got encoded and encrypted information. With AES 256 encryption, you would need about 1 billion years to decrypt that character. And you'd be left with contextless, meaningless information because it represents nothing. When you're ready to withdraw it or retrieve it, we'll transfer that out and hand it to another server called an API server. This is talking directly to the web server again. The web server now generates a new security secret, hands it to the API server. It receives part of a security secret originally from the mobile phone and can start the deciphering process, but then further encodes it. It hands it back into the web server, which has the original security secret for this transaction, and decodes it inside there. This happens in milliseconds. On top of this, we can also add your Face ID, your fingerprints, your screen pattern on your phone, something to prove that you are present. Your Face ID, your ID never leaves your device. It's held in a secure enclave on that phone, and it's using public key encryption. basically say, yes, this is you that set this up originally. We know it's you. This architecture scales massively. A small virtual machine can have file handles pushed up to about 32,000 concurrent connections. 32,000 phones can be connected really for milliseconds. And we can set up a high availability cluster of these and spread these around the world. The actual records in the database are a few hundred characters for each line. It's all in RAM. As I said, this will scale to easily tens of millions of users or more. That's it. The ask is really just test drive this for yourself. It's very simple to set up. And if you're worried about this at all, just get onto a Zoom call with us and we can go through this demo in literally 5 minutes. Thank you very much, and we look forward to speaking to you.